Roman engineers and legionaries carved roads through mountains once believed impossible to cross, raised amphitheaters for tens of thousands within a few short years, and built fortified military camps in mere hours. Their achievements appear almost supernatural, yet there was no magic, only precise calculation, flawless organization, and engineering methods so advanced that some remained lost for centuries. Many of their creations, from roads to aqueducts, still function 2,000 years later. Watch to the end, and you'll discover how Rome managed to stay centuries ahead of its rivals. What secret material allowed them to build underwater? And why was a disciplined legionary with a shovel far more powerful than one with a sword? The greatest secret of Roman engineering is not a single invention, it is a philosophy. While the Greeks aimed to craft unique masterpieces, the Romans embraced a new idea: complete standardization. This mindset allowed them to copy and replicate entire cities, bridges, and road systems across vast territories at astonishing speed. Their goal was never artistic uniqueness, it was pure functionality, speed, strength, and durability multiplied across an empire. For Rome, engineering was as powerful as law or the legionary's spear. A road could Romanize a distant province, a flowing aqueduct made a frontier settlement feel like the capital. Their utilitarianism became absolute. Every architect and engineer served the state. Instead of reinventing designs, they perfected and repeated the best ones. They adopted the arch from the Etruscans, refined it, and used it to build everything from bridges to the Colosseum. Instead of designing 100 kinds of bridges, they built one perfect model 100 times. Standardization reduced design time, simplified training, and allowed engineers from distant provinces to work anywhere in the empire with the same tools and measurements. Everything was regulated, from brick sizes to mortar mixtures, from road widths to construction sequences. This allowed them to calculate materials, manpower, and logistics with scientific precision. Where other civilizations adapted to the landscape, Rome reshaped it. If a straight road required cutting through a hill or tunneling beneath it, they did so without hesitation. This directness was both practical and political. That is why Roman colonial cities looked like a rectangular grid, a central forum, baths, theaters, temples ready to be deployed anywhere. A new legion arriving at a site already possessed a complete template. Rome created the world's first engineering system, where knowledge was not controlled by individual craftsmen but became a state resource. They built an engineering assembly line 15 centuries before Henry Ford. Their speed came not from lone geniuses but from a synchronized system organization, logistics, standardization, and a massive, disciplined workforce. So was their obsession with uniformity a sign of brilliance or a lack of creativity? Share your thoughts in the comments below. And make sure to subscribe to see how this system functioned in real life, especially how Rome's most powerful construction company was its own army. Are you ready to discover what Roman legionaries really did during most of their service? We picture them with swords and shields, but their daily reality was far more practical. Legionaries spent more time with shovels, axes, and saws than with weapons. The Roman army was the empire's largest construction force. Each legion of about 5,000 men functioned as a highly trained engineering brigade, capable of building anything using only its own resources. On campaign, every soldier carried not just weapons but also a toolkit, a pickaxe, a saw, baskets for earth, stakes for palisades. Engineering was built into Rome's military doctrine. The army didn't simply conquer, it anchored itself into the land. They built roads for rapid movement, bridges to cross rivers, and fortifications to secure newly taken territory. Every military campaign doubled as a massive construction project. Within each legion, there were specialized troops known as immunes, engineers, surveyors, carpenters, masons, blacksmiths, and siege engine builders. Discipline that made legionaries deadly in battle made them unstoppable on construction sites. They worked in shifts, maintained strict quotas, and never stopped. While some dug trenches, others guarded them. When a commander needed a road, bridge, or fortress, he didn't wait for contractors, he already commanded thousands of trained builders. Engineering was mandatory military training. Recruits learned to build ramparts, dig trenches, and assemble wooden bridges. A soldier unable to use a shovel was considered just as inadequate as one who couldn't handle a sword. It was the legions that built most of Rome's vast road network, cutting forests, leveling ground, laying foundations, and paving the surface to military standards, straight, stable, and built for speed. Even monumental structures like Hadrian's Wall were constructed by legions themselves. They didn't just defend the fortifications, they built them stone by stone. This military engineering hybrid gave Rome unmatched strategic mobility and territorial control. But what exactly were they building with such speed and confidence? The answer lies in a material so advanced that modern science only recently rediscovered its secrets. It made Rome's structures faster to build, cheaper, and stronger than ours. This material, Roman concrete, could even harden underwater. Its formula remained lost for 1,500 years. We often imagine Rome built from marble, but its true miracle lay in opus cementitium, Roman concrete. Earlier civilizations knew primitive forms of concrete, but the Romans perfected it. The key ingredient was pozzolana, volcanic ash from the region around Mount Vesuvius. When mixed with lime and water, it triggered a chemical reaction that created powerful crystalline bonds, turning the mixture into a single solid mass. Unlike modern concrete, Roman concrete didn't need air to harden. It cured perfectly underwater, allowing engineers to build ports, bridge foundations, and aqueduct bases in wet conditions that would destroy modern cement. Construction was fast and economical. Instead of pouring liquid concrete, they filled wooden forms with alternating layers of mortar and rubble. This technique required far fewer skilled masons and was perfectly suited to legions and slave labor. Concrete unlocked the full potential of arches, vaults, and domes. It made possible structures like the Pantheon's massive dome, the largest and reinforced concrete dome in the world even today. Over time, Roman concrete didn't weaken, it grew stronger. Seawater reacted with the volcanic ash, forming new minerals that filled microcracks, creating a material that could heal itself. That's why Roman harbors still stand while many modern ports crumble. Cheap, fast, durable, and astonishingly strong, Roman concrete allowed engineers to build at imperial scale, transforming landscapes and cities with a material centuries ahead of its time. If this fascinates you, don't forget to like the video and subscribe to the channel. I'll be revealing more unbelievable secrets of ancient Rome soon. Now imagine a road built 2,000 years ago so precisely that modern highways still follow its path. The Roman road network wasn't just infrastructure, it was the physical expression of imperial power. And its core principle was simple: absolute straightness. When planning a route, Roman engineers didn't seek easier terrain. Their duty was to connect to points by the most direct line possible. Mountains were cut, tunnels dug, swamps drained, the road bent nature to Rome's will. They used clever but simple tools to achieve this precision. The gromata crossed beams with plumb lines allowed surveyors to establish straight lines and perfect right angles over long distances. The chorobates, a long water-level beam, ensured accurate gradients on ascents and descents. The dioptra, an early theodolite, provided more advanced angle measurements. A straight road symbolized Roman authority, order imposed on the natural world. Surveying teams could map kilometers of road within a day. Legions then cleared forests, leveled terrain, and began earthworks without delay. Roads were built for military use, prioritizing speed and durability. Heavy local traffic was sometimes restricted to prevent damage. Settlements later grew around these routes, creating new economic centers. Milestones were placed every Roman mile, constant reminders that every road led to Rome. Their efficiency was unmatched. Once a route was marked, construction moved forward relentlessly. In the next chapter, we will dissect a Roman road layer by layer to reveal the engineering inside it.